At 30,000 feet, outside your airplane window, the air is so thin you'd pass out in seconds. Inside, you're sitting comfortably, breathing like nothing's wrong. Now here's the weird part. That tiny hole in your window, barely the size of a pin, is one of the reasons you're still alive. No alarms, no attention, just a silent little hole controlling life and death. And once you understand why it exists, you'll never look at airplane windows the same way again. Let's zoom out for a second. A commercial airplane is basically a pressurized metal tube flying at 800 kilometers per hour, higher than Mount Everest. Inside the cabin, it's like being on a mountain about 6,000 to 8,000 feet high. But outside, the pressure is so low it's almost like space. That means the airplane is constantly fighting a massive force. The air inside is trying to explode outward, while the air outside is barely pushing back. We're talking about thousands of kilograms of force pressing on every window. So how does a thin piece of plastic and glass not just shatter? Early airplanes didn't always get this right. Back in the 1950s, the de Havilland Comet, one of the first jet airliners, had square windows, and that tiny design choice caused disasters. Why? Because sharp corners concentrate stress. Over time, tiny cracks formed, and eventually catastrophic failures happened mid-air. That's when engineers realized airplane windows need to be oval, not square. But even with that fix, there was still another hidden problem. To understand the tiny hole, you only need to know one thing. Airplane windows aren't just one layer. They're actually made of 3 layers. The outer pane takes the pressure, the middle pane, a backup safety layer, the inner pane, the one you touch. And that tiny hole? It's in the inner pane, which is strange because that's the one closest to you. So why put a hole there? Imagine this. You're holding 2 plastic sheets, one behind the other. Now imagine blasting one side with air pressure. If both sheets take the pressure equally, they both weaken over time. But what if you could force only one sheet to take almost all the pressure? That's exactly what the tiny hole does. Here's how it works. The hole allows air pressure to equalize between the cabin and the space between panes. So instead of the inner pane sharing the load, the outer pane takes almost all the pressure difference. The middle pane is just backup, and the inner pane? It's basically just there to protect passengers from touching the structure. But here's the interesting part. If that tiny hole gets blocked, the pressure starts distributing the wrong way, and suddenly the inner pane, the one never meant to handle stress, starts taking load. During every flight, as the plane climbs, cabin pressure is carefully controlled. Meanwhile, outside pressure drops dramatically. That difference builds up across the window system. Because of the tiny hole, the outer pane flexes slightly outward, the middle pane stands by as backup, and the inner pane stays almost stress-free. It's a constant balancing act, happening quietly beside your seat. Here's something most people don't know. 1. Windows actually flex during flight. They bend slightly outward under pressure, like a balloon, but controlled. 2. The tiny hole also prevents fogging. It allows moisture to escape between layers, keeping your view clear. 3. If the outer pane fails, you wouldn't even notice immediately. The middle pane is designed to handle the pressure safely until landing. But that's not the full story, because that tiny hole isn't just about pressure, it's about control. Without it, the entire system becomes unpredictable, and in aviation, unpredictability is the real danger. So that tiny hole you've probably ignored your entire life is actually a precision-engineered pressure regulator. It decides which layer takes the force, prevents fogging, and helps keep the entire window system stable at extreme altitudes. It's small, almost invisible, but without it, flying safely at 30,000 feet would be a completely different story. Now here's something even more interesting. Airplane windows are small for a reason too, and it has to do with something your body does during flight that most people never notice.